So welcome back guys. In this particular session we'll be talking about the light, sound and the radiation, right? So let's talk about some important terms about the light first of all, right? So we are gonna begin with the light. So light in itself is a very beautiful phenomenon, right? So if you talk about the festivals also, right, for an example Diwali and all, so lights are a very important factor over there, right? And it brings beauty to the life. So basically, if you talk about the light, we are having four important terms, among which the units are asked very commonly in the MCQs. So these terms are the luminous intensity, luminous flux, what is the luminance and what is the illuminance, right? So basically, if you talk about the luminous flux, here the unit is the lumen, right? Luminous flux, right? There is an inverter named as luminous as well, by the way, so you can remember that by that also. So luminous flux is having the lumen, right? That is an SI unit, right? There is an SI unit, and there is a luminous intensity that is having a SI unit as candela. Luminance, it is having the SI unit as candela per square meter, right? And if you talk about the illuminance, it is having the SI unit as lux or lumen per square meter, right? And these could be the symbols are not that important, but what is important is the SI unit, right? Now if we talk about the basic minimum illumination which is needed for the satisfactory vision, right? For example, you are studying, right, and you are opening the book, you are reading something from the book, you need some of the light to read it, right? That's how your cones will be able to work in your eyes, and that's how you will be able to read something, right? Now you must have observed that if there is too much of light, then also it is not that then also it is quite uncomfortable for you to read that particular content. And if the light will be very dim, then also it is not that comfortable, it is not quite comfortable for you to sit down and read for the long hours, for an example, right? So you need just for the satisfactory vision, you need just a good light over there, right? And this good amount of light should be there. So what should be the nature of the light also, we'll talk about that as well, right? So just take that example, open the book in front of you and just take that example, that just that intensity of the light you need. And sometimes what happens is that if the light intensity is just right, then your tendency to read also, it becomes longer. So basically, if you talk about this particular light, right? So first question which I'm going to discuss, first question, that was the SI unit of these four important units only. But next question which I'm going to discuss over here is that what is the basic minimum illumination which you need for the satisfactory vision, right? So the basic illumination which is needed for the satisfactory vision. That was a question, by the way, earlier asked. Satisfactory vision. So that is your 15 to 20 foot candles, right? 15 to 20 foot candles. I'm talking about this one over here, right? Illumination. So over here we are saying that if it is 20 to 40 foot candles, right, then we are saying, or 15 to 20 foot candles, right, 15 to 20 foot candles, then vision, right, that is 15 to 20 foot candles, then that is the basic illumination which is needed at least for the satisfactory vision, right? Now what are the requirements for the good lighting, right? You are reading your book right now, so for an example, so what should be the good criteria for the good lighting? What should be the criteria for the good lighting? So let's talk about this criteria for the good lighting as well. So the criteria for the good lighting are, first criteria which we need to understand, which we need to remember over here, is that is sufficient light, right? Sufficient light to prevent the straining of eyes, prevent the eye straining, right? Obviously when we are reading, obviously when we are reading, the light is very important, otherwise our eyes will be getting strained, right? And sometimes you will be feeling the headache as well, right? Because there is not a proper light in which you are reading right now, for an example, right? Second criteria over here is that what is the distribution of the light. So light distribution must be uniform, so that is also very important. So uniform light distribution, there should not be any kind of glare in the light, so there should be absence of glare, right? what should be the color of the light? Is it should be yellow color or red color or green color? No, nothing like that. It should be white color. It should be white in color. Usually when you're reading, you are preferring, in your houses also you are preferring that there should be whatever lamp you are purchasing or buying, it should be having the natural light in it, right? White color natural light it should be having usually, and we are avoiding the old kind of yellow kind of lights, right? So basically nowadays we are having that is your natural color lights, basically the white color light. So color of the light should be daylight color. So what should be the color of light? Color of light, it should be daylight color. Okay, it should be daylight color. Next point over here is what about the reflection factor? When the light is falling on some surface, then it is getting reflecting back as well. So on different surfaces, it is having the different percentages of reflection. So now we shall talk about fifth factor, again very important one, that is the reflection factor. Okay, fifth factor, that is the reflection factor. Right, so in the room we shall be having different surfaces obviously. For example, if I am having ceiling or roof, whatever you want to call it, ceiling or roof, okay, it will be having 80% of the reflection factor. It should be having 80% of the reflection factor. If you talk about the wall, right, it should be having around 50 to 60% of the reflection factor, right? If you talk about the furniture, it should be having around 30 to 40% of the reflection factor, 30 to 40% of the reflection factor. And at last, if you talk about the floors, then it will be having the least one, that is around 15 to 20% of the reflection factor. 15 to 20% of the reflection factor. Reflection factor means the amount of light which is getting reflected back on after falling onto the surface, right? So these are the reflection factor which we must remember, because very commonly tested in the MCQs as well, right? There should be a constant source of light. It should not be like this, that at one point of time the light is coming from here, at one point of time light is coming from there. There should be a constant source of the light. That is also the important point over here, which we shall add on. So sixth point over here, which I am adding that there should be a constant source of light, so that our attention is not getting deviated. Okay, that is also important. Now there is a concept for the artificial lighting also. In the artificial lighting we are talking about the direct light and the indirect light. Obviously in the night time we are using the artificial light only. Natural light we are getting from the sun in the daytime only, right? So basically if we talk about the artificial lights, okay, artificial lights we are generally using in the night time, right? Usually in the night time, because in the daytime we shall be having the sunlight also, but in the night time we are not having that. So we are using the artificial lights for that. We might be using the LEDs, we might be using the CFL lamps, right? But nowadays we are actually preferring the light emitting diodes, that is the LED lights over there, right? Okay, and we are having the different electronic gadgets for the LEDs, right? So if you talk about the artificial lights, we are having two kinds of lights in this case. One is the direct light, one could be the direct light, and another one could be the indirect light. Okay, these are very simple to understand in themselves only, because if you talk about the direct light, right, it is actually coming from one source. For an example, this is the source over here in front of you, right? And here we are talking about, if this is the surface and this is the light over here, so it is actually falling onto this surface. It is actually falling onto this surface, right? So this is the direct light which you can see right now. This is the direct light, right? Now if I will be covering it with something, right? If I will be covering it with something, let's say there's a paper, right? I will be covering it and then it will be scattering some light over there, then it will be called as the indirect light, right? I hope you got the idea that what is the direct light. Direct light means coming from the source. For example, you are seeing that your LED light over there, right in front of your roof. So basically that will be the direct light. If you're covering that with something, that will be the indirect light. For example, let's say this is your home, right? Beautiful home over here, and what we can see over here, these are the direct light sources. These are the direct light sources. But you are seeing that beautifully LED is actually covering like this, your ceiling, right? Or they are just covering your beautiful, wooden ceiling. Then this is the indirect light. The light is coming out from that. This is the indirect light, because you are not seeing that directly. Actually light is coming from that, but that is the indirect form of light, and here the light is coming directly, isn't it? So I hope you got the idea over here what I'm talking about. So these are the examples of the direct or indirect light, right? Obviously at what point of time, you will be needing direct light. For example, if you want to read for an example, so at that point of time you need the direct light. Or if you want to relax, then at that point of time you want the indirect light. Because what are the concepts of using the indirect light? Usually when we want to relax, right? So we don't want complete dark, but at the same time we want some light also. So at that point of time indirect light is best. Usually direct light is actually directly coming from the source to the surface. And if you talk about the indirect light, there is a source, there is a surface, but in between there is an obstruction, and that obstruction can be some of the extra ceiling, surrounding structure. For example, lamps are also coming, the nighttime lamps actually having that thin surface surrounding the lamp, surrounding the source. So that is working as an indirect lamp source, right? So there could be many sources over there, right? So indirect light, actually in the indirect light we are seeing that there is a source and there is a surface. From the surface, light is falling onto the surface, right? From the source, the light is falling onto the surface. Just now I showed you the example as well. Now in the indirect light we are seeing that there is a source, yes, then there is a surface, again yes, but in between that we are putting one obstruction over there, right? We are putting one obstruction over there, right? It might be some thin obstruction, so that direct light is not falling onto that particular surface. This particular surface is actually working as a filter, right? So that filter, if it is there, then it is the indirect one. For example, here you can see you are not seeing the direct light, right? You're not seeing this is the indirect light example. This is the indirect light over here. There is the filter. The corners of this is the filter over here. Actually LED has been placed over there, right? Okay. So this is example of indirect light. Once you understood this concept, right, we are having three important sources, right? I would say three important examples rather. One is the light sources. Here I am writing, okay, light sources, right? Here I am writing the light energy, and here I am writing the heat energy, right? I am just shifting this picture to more upper side so that we shall discuss some more concepts over here, right? And here I am writing the heat energy, right? So in the ancient time, just 5 to 6 years back, we were having what, or 8 to 10 years back, we were usually having the old yellow color bulbs, right? They used to consume a lot of electricity and were giving, used to exert a lot of heat also, right? And then it was giving the light. So those kind of bulbs, actually they were, if you remember guys, they were tungsten bulbs, right? I mean they were having the tungsten filament bulb, and they used to get fuse also. And once they used to get fuse, you used to check, right? You used to check like this kind of bulb, and if the filament was displaced, then you used to understand that yes, it is already gone, right? If not, then you used to try other kind of methods to glow it up, right? So that was the tungsten filament bulb. Then you came up with the CFL lamps, right? Chlorofluorescent lamps over there, CFLs, okay, CFL lamps. And after that, nowadays we are using the LED lamps. Okay, after that we came to the LED lamps, right? So this, all of this journey actually happened from your childhood till this point of time now. Okay, all of you, I'm sure you must have seen these three out of three lamps, right? Over here, light energy, if you talk about, right, actually tungsten filament lamp or tungsten filament bulbs, actually they are very bad. They're just producing 5 to 10% of light energy out of them, but a lot of its energy is actually wasted. 90 to 95% of the energy is getting wasted in the form of heat only. So that's why we came up with a new innovation, okay, somewhat better, and we started producing the CFL lamps. CFL lamps, what happened with the CFL lamps, it started to produce more amount of light, 20-25% of the light, but at the same time heat energy was more in itself, so it was around 75 to 80% was the energy which was actually getting lost from it, right? So it was also not good option, but better than the tungsten filament lamps. And then we came up with a very efficient method, very efficient lamps, okay, very efficient source of the light, that is your LEDs lamp, right? LEDs lamp are very, very efficient. They are actually giving the 70 to 75% of the light, and wasting is very, very less over here. Only 25 to 30% of the energy is getting wasted in the form of heat energy, and that is about the LED lamps. So here you can see, these are your beautiful, which lamp? Tungsten filament lamp, but at the same time they are getting heated very soon, and they are generating the light energy, but mostly it is generating the heat only. These are your CFL lamp, right? I know most of you guys must have seen the CFL lamps, and then there are the LED lights. Okay, and we are having the LED lamps also, right? So we are having the LED lamps or LED lights. Okay, and the Diwali time you are using the LED lights also. So this is the thing. Okay, so once we understood this about this one, right, now we shall talk about the one scheme which is actually promoting the LED lights, and that was the Ujala scheme, right? That was the Ujala scheme, and here they came up with this particular scheme. Basically this was the Ujala scheme. Ujala scheme actually started promoting the LED lamps, right? So here is it is the symbol for the Ujala Yojana, Pradhan Mantri Ujala Yojana. Here they wanted to promote the LED lamps because it was wasting very less amount of energy, and the efficiency power is very, very high over here. So most of the part of energy is actually giving off by emitting the light, and less part of it is getting wasted into the heat over there. So it is kind of a better way to generate the light basically, and so that in many places we can send the light. Okay, so that's why Ujala scheme was actually preferring which lamps? LED lamps. Okay, so please remember that it was the national saving of electricity. Okay, they were actually promoting the national saving of electricity. So Government of India promotes the usage of LED. GOI, Government of India promotes LED lights uses, right? LED lights uses, and they say that this is a better way of national saving of electricity. Okay, so that we can send the electricity in those areas also, and we can actually glow the lights in those areas also where the light has not been reached yet, right? So this is the thing over here. Then we came up with one important factor which we have earlier talked about, that was the daylight factor, or it is also abbreviated as DF. So what is the daylight factor? Daylight factor, here we are saying that it is actually a method to measure the daylight. It is actually measuring what? It is measuring the daylight. It measures daylight. Okay, now there is a formula for calculating the daylight factor, guys. What is the formula over here? The formula is amount of illumination outside, inside rather, amount of illumination inside or indoors divided by amount of illumination outdoors, amount of illumination or amount of light, okay, whatever you want to call it, outdoors, and multiplicative factor will be 100. Okay, sometimes they can ask you this kind of question. Okay, you just need to put the values in this question and put the values in this formula, and then you can get the answer over there, right? Okay, by the way, for the dark room, guys, what should be the DF? Right, there are some questions. For the dark room, what should be the daylight factor? For the bedroom or for the dining hall, right, what should be the daylight factor? And for the kitchen, what should be the daylight factor? These three questions must be known to us. So guys, for the dark room, basically they are saying that it should be less than 2 daylight factor. For the kitchen, it should be less than 10 daylight factor, and for the bedroom or dining hall, it should be less than 8 daylight factor. Okay, so for the dark room, less than 2. For the bedroom, it should be less than 8 daylight factor, and for the kitchen, it should be less than 10 daylight factor, right? Now some of the standards we need to understand over here. Okay, some of the standards we need to understand over here, which are very important for the exam point of view, that the visual task and the illumination. So sometimes they ask you, for example, if you are usually reading, if you are just a casual read, right, how many lux of illumination, how many lux of light you will be needing over there? So this kind of question might be asked. Okay, and we should be able to answer them. So on one side I am writing the visual task, on another side I am just writing the illumination. Okay, the SI units has already been covered, so please go through that as well. SI units are also very important. Generally they are asking you. So if you talk about the visual task, guys, here one question can be that what about the casual reading, right? Then what about the general office work? For that purpose, how much illumination will be needed, right? Next question, for the assemblies, final assembly, right, what should be the light? Then very severe task, or the task who needs which needs utmost attention, so you will be needing more amount of light. For example, now after that there is a watchmaking. So for an example, you are performing a surgery onto the patient. Obviously the negligence chances are very, very less over there, so you want the best light present over there, okay, because you wanna know the minor structures could be present over there. There could be the arteries, there could be the nerves, and all of these things, they might be getting cut, right? So for that purpose we will be needing a good amount, a good source of light over there. So the intensity of the light, intensity of the illuminance should be high over there, isn't it? So that is the thing. Okay, so now let's talk about them. In the casual reading, if I'm talking about, we will be needing about 100 lux. If you talk about the general office work, then it is around 400 lux. If you talk about the fine assembly, it is around 900 lux. Okay, very severe task, 1300 to 2000 lux. And for the watchmaking, right, very particular task, right, which will be needing the utmost attention, that will be 2000, around 2000 to 3000 lux approximately. Okay, so this is very important. Any one of the point might be asked, right? So that should be non-bias. Okay, so very important MCQ question, guys, right? Now next point over here, after the light we shall be moving on to the sounds. Yes, we shall be moving on to the sounds, a very important part of us, right? And we are able to hear any kind of sound by the help of our ears. So thanks to the ears over here, we are having two. Now if you talk about the sound, guys, then what is the unit of sound measurement? That is the very first question which can be asked. So first question, that is unit of measurement if I'm talking about the sound. So two measurements have been actually defined over there. One is intensity and another one is the frequency. So one is intensity and another one is the frequency. It is having, both of them are having the different units. For the frequency we are using the hertz. I'm just writing the HZ, that is denoting the hertz over here. And for the intensity we are denoting it with the decibel. Okay, so both of the terms, yes, you must have heard about them already, right? Now if you talk about one more, if you talk about the unit, there is one more unit, guys. This is named as the phone, PHON. This is the phone basically, and this is the, they are saying that this is the psychoacoustic unit of measurement. Actually psychoacoustic unit of measurement, and they are saying that it is a combination of both intensity and the frequency. It is the combination of both, that is frequency plus intensity. So decibel and the hertz is a combination of both, and remember the name over here, that is the phone. Okay, now next point is, what is the important questions only that has been asked. I have just collected them at one place. Once they asked us, this is the question only. So first question we shall write over here, right? So I will be discussing the questions now. So first question from the sound. Okay, they have asked us once that what is the permissible sound limit. So it is permissible sound limit is less than 85 decibel. So permissible sound limit will be lesser than 85 decibel. So please be very clear with that. Second question they had asked us once. Okay, second question they had asked us that what is the audible range. Audible range, you must have heard about that in your early classes also, in the physics 9th and class physics. So the audible range for our ears, right, audible range of sound, that is 20 to 20,000 hertz. 20 to 20,000 hertz, that is your frequency, right? Next question they had asked us that what is the normal conversion frequency. So that is normal conversion. So normally you are just talking, for an example, that normally what will be the frequency range, that is around 60 to 65 decibel. What is the whispering range? You are just talking to your friend in the ear only. So what is the range over there? So whispering range has been asked. Whispering range, if we talk about, that is 20 to 30 decibel. Okay, that will be 20 to 30 decibel, because we know that 20 to 20,000 hertz is the normal audible range. 20 to 30 decibel on the lower side, it is the whispering range, right? Normal conversation when we are doing, that is the 60 to 65 decibel, right? And now it depends on the frequency of the sound. Some person might be having some higher frequency of sound comparatively, or some person might be having the lower frequency of sound, but generally the range The average range is 60 to 65 decibel of the normal conversation, right? Okay, so these were some of the MCQs which we need to know as far as the sounds are concerned, right? And one more thing over here, if you talk about the sounds and the hearing impairment, right? Usually they are asking us at what frequency, at what intensity, right? Or at what frequency we are saying that, the grades of hearing. So at what frequency there will be the impairment of the hearing loss. So these kind of question might be asked. So let's discuss these kind of question as well. So here we are talking about the sounds and the hearing impairment. Sounds and the hearing impairment. On one side I will be writing the intensity of the sound, and at another side we'll be writing the hearing impairment. So intensity of sound, and on this side let me write the hearing impairment. Okay, so let's talk about them as well. So the very first one which I am taking over here, that is what will happen if the frequency, or if the intensity, frequency will be measured in the hertz. So this is the intensity. So if the intensity will be more than 85 decibel, then we are saying that there is no problem, no impairment, right? There is no impairment, because I told you that permissible sound limit is less than 85 decibel. Less than 85 is no problem. 85 or less than 85 is no problem. There is no impairment. But the problem starts after this 85. Okay, these values might be differing, which I'm going to tell you now, because in some books they are giving the different values, some books they are giving the different values. Plus minus 10 you can adjust over there, right? So next one, if it is getting more than 90 or 95, more than 90 or 95 decibel, then they are saying that this is a temporary hearing loss. This might be causing the temporary hearing loss. Temporary hearing loss. If it is around 100, decibel intensity, then it might be causing the permanent hearing loss. It might be causing the permanent hearing loss. And if it is crossing over 160 decibel, then it might be lethal to our tympanic membrane inside, which is responsible for transferring the mechanical sound into the the physiological sound basically. So if the tympanic membrane will be getting damaged, what should be the threshold of the intensity? That is around 160 or 165 decibel. So if that much will be the intensity of the sound at around 160 decibel, then it can cause the rupture of tympanic membrane, right? So it can cause rupture of tympanic membrane. Okay, and that was the MCQ, guys, once had been asked, right? Now, what are the grading of the hearing loss? Let's talk about the grading of hearing loss. Grading of hearing loss. Okay, if we talk about the grading of hearing loss, right, we might be having the grade 1, grade 2, grade 3 and grade 4. Over here we are saying that if the intensity of the sound is less than 25 decibel, it means that there is no impairment generally. No impairment generally. Okay, if they are saying in the question that it is between 26 to 40 decibel, then there could be slight impairment to the hearing. Slight impairment to the hearing loss. If they are saying that it is between 41 to 60 decibel, then there might be the moderate impairment of hearing loss. Moderate impairment of hearing loss. Then if it is 61 to 80 decibel, then it is the severe category of hearing loss, right? Severe impairment of hearing loss, severe impairment. And if it is more than 81 decibel sound intensity, then obviously we are saying that it is the profound hearing loss or the profound impairment of hearing loss, right? Profound hearing loss. Okay, profound hearing loss. It means the person is deaf probably, right? Okay, now let's talk about the radiation, right? Now let's talk about the radiation, and these are some of the units which we need to talk about over here. So now we will be talking about the radiation. Okay, in the radiation we shall talk about these units. In the units we are talking about 4 important units over here, which we need to, 4 important quantity over here, about which the SI unit they are asking us. So first one is the exposure, then there is a dose, then dose equivalent and the activity, right? Which activity? This is the radioactivity, right? This is the radioactivity. Okay, if we talk about the radioactive exposure, then here, earlier we used to talk about the Roentgen, but now we are talking about the Coulomb per kg, right? These units you must have heard about them in the radiology section as well, dose in the initial chapters basically. If you talk about the dose, it was rad actually earlier, but now we are actually using the term that is gray, that is the SI unit these days. Dose equivalent, if you talk about, earlier we used to use the rem, but now we are talking about the C word. Now we are talking about the C word. Then if you talk about the radioactivity, we used to use the Curie in the earlier time, and now we are using the term Becquerel for that, right? Term Becquerel for that. So you actually need to remember this particular line, right? Because this is the updated one, this is the updated SI unit, right? Okay. Now we shall move on to the most important part over here, that what are the dose limits of the radiation exposure, right? So let's talk about the dose limits of radiation exposure. Here we shall talk about the occupational exposure, we shall talk about the general public exposure, right? So the very first one, let's talk about the occupational exposure. Okay, occupational exposure, for an example, a person is working in that particular, for example, you might be working in the radiological department, right? Or somebody is working in that department where it might be the nuclear power plant, or some workers might be working in some category where the radiation might be emitting out, right? So in that category, for the occupational exposure, they are saying that it should be lesser than 20 millisievert per year, 20 millisievert per year, because above that there are some changes which might be seen in the body if the radiation will be coming into the body, right? Second one which we shall talk about, first was the occupational exposure, second one is the general public exposure, and third one general public exposure, right? And third one could be the pregnancy, right? Third one could be the pregnancy. Okay, so for the general public exposure and the pregnancy, it will be the same, right? So for the pregnancy, we are saying that less than 1 millisievert per year, and for the general public, if I'm talking about, then it will be the same, that is the less than 1 millisievert per. Okay, so that is about the dose limits of the radiation exposure. Very commonly they are tested, right? I know this could be the the memorization part, but that's how it is, right? We need to know about these values. For the general public exposure and pregnancy, it is safe. It is same actually, that is less than 1 millisievert per year, and for the occupational exposure, that is less than 20 millisievert per year, right? Now we shall talk about the types of radiation. If we talk about the types of radiation, right? Then we are having first one, that is the ionizing radiation. So the very first one, this is the ionizing radiation, and we might be having the non-ionizing radiation. Ionizing radiation, second one could be the non-ionizing radiation, right? In the ionizing radiation, we are talking about pattern, right? And basically this pattern has been decided according to the wavelength, right? More will be the wavelength, more lethal will it be. For an example, if you talk about the ionizing radiation, we are saying that if it is rays, alpha rays are very, very dangerous one, then there is a beta rays, then there is a gamma rays, and then there could be the X rays, right? So who will be having the highest wavelength over here? So no doubt about that, the alpha wave will be having the highest wavelength, right? Highest wavelength, and the X rays will be having the lowest wavelength, right? This is the sign for the lambda, so that's why I'm just using it. Okay, this will be the sign of lambda, right? This is the lambda, and lambda is the sign for which we are denoting the wavelength, right? For the non-ionizing radiation, guys, the pattern would be, first of all, there is radio frequency waves, right? Radio frequency waves are there. Radio frequency waves are there. After that, there are the microwaves, right? Then there could be the infrared waves, and at last there could be the ultraviolet rays. Who will be having the highest wavelength over here? The highest wavelength will be having the radio frequency waves, and the lowest will be the UV rays, right? So here the UV rays will be having the lowest wavelength, right? This sign is for the lambda sign. Again guys, I am telling you, lambda is for wavelength over here, right? So wavelength, I am going to denote it with the lambda color, right? Lambda basically. So here these are some effects, which can be seen on the public or the population if the radiation dose will be increasing. What is the maximum permissible dose? That is for the humans, they have decided, maximum permissible dose for an year. So guys, this is also very important question. Maximum permissible dose for radiation exposure, okay, that is radiation exposure that is less than 5 rads per year, okay. So that is the thing. Now we are seeing that if there is 0 to 25 rads, then usually we are seeing that there is, okay, I will be taking this color, 0 to 25, then there is no observable effect. But if it is crossing 25 to 50, then there could be the minor temporary blood changes. Then if you talk about 50 to 100, there could be possibly nausea can be there, vomiting can be there, leukocytopenia can be there, okay. These kind of symptoms might be appearing in the patients. If it is 150 to 300, probably the severity of the nausea, vomiting, diarrhea, it might be increasing, and with that loss of appetite can be there. Some of the hematological changes can also be appeared. 300 to 500, if the rads are increasing, radiation exposure is increasing, then there might be the hemorrhage, there might be the depletion, and in the severe cases, there might be the severe nausea, vomiting, diarrhea, hemodynamic changes will be appearing in the patient. In some cases, death might be there as well, right? More than 500 is very, very lethal. Here, the symptoms will be appearing immediately, and then at last, the expiry might be seen. Right? The radiologist, right, on annual basis, very frequently, they are just getting checked for their radiation exposure, right, because they are working in the radiology departments. Same goes with those persons also who are actually working in the radiation field, in the radiation exposure, because it is not good for the body, it is harmful for the body. So that's why, you must have seen that if the X-ray is happening in surrounding, in your ward or in your unit, then probably the technician will be asking you to leave the room, because there would be the radiation. And X-ray, however, it is having the lowest wavelength, so causing the less damage, but still it is harmful for our body, right? So that is the thing over here. Okay, so that was about the radiation, guys. So I hope you enjoyed the topic, and I will be seeing you in the next one.